Welcome back, Rashid here, and today we are going to revise what we did in work week fourth. Not work week fourth, week fourth. Okay, so this course is RISC-v architecture, and this is part of a bigger training series. And the objective is that I'm going to develop a low cost, low power RV32i core using free and open source tools. Yes, there is a reason why I'm doing this, and I'm not gonna go into that. I will do a separate video. I know there are different opinions. What's the point of doing with open source? But I think there are some good reason for that. Okay, and right now this entire series is going to be for the membership, even though I bring a lot of free videos out of that series for you every week. And also this revision that I do every week for what I did during the week. It's a quick revision, but I bring this free as well. Membership, if you are in US, Europe, is $299 a month. And for other countries, you can check, it will be something different, not exact equivalent of that. Okay, and you need to go to desktop in order to get the membership or join it. Overall, where we are in this overall picture is we are in the architecture phase, and next will be the implementation, validation, and physical design. Roughly, I think it's gonna take me a year because I do this along with my full-time job. So only when in the evening and weekends when I get time, then I study and prepare stuff for it. Okay, all right. So let's get started. So what we started the week, it was with unconditional branching. In the beginning, I only look into J instruction. These two came later on during the week in the function, and we will look into more in the week 5, because week 5 we will be looking into stack and functions upgrading, the example that we start with. Okay, so in this example, I explain how you can use labels to jump to a particular location. And this is unconditional because, we just jump anyway. Okay. Then we went into if else. If in a higher level language like C code or Java or Python, you have some if else or case switch type of constructs, then how are those going to be converted into assembly language for RISC-v? And keep that in mind that the assembly language gives us a good understanding of what we are going to implement later on in hardware. So right now we are learning specs of RISC-v basic core, and later on we are going to implement those specs in hardware. Okay, so that's why we are going through this architecture. And I mentioned that, okay, whether it's if else, case switch, all those condition, and later on even some of those for or whiles, those are all, in all of those, the key thing is we first check a condition, and for checking that condition we use conditional branches. So here, if we are checking for equal, the conditional instruction that we're going to use is not equal, because when it's not equal, we want to jump all the way to the end. If it's equal, then we want to execute this instruction in sequence. That was an important thing, and I gave plenty of examples around that. Okay, so you have a condition and you jump to a label, and label is here. Make sense? Now there's a difference between right now that if this condition meets, we execute in sequence. If not, we make a jump. And that's what I mentioned here. This is the instruction that we execute in sequence, and this is the one, this is outside that if. Okay? Anyway, if you want details, go to that video. Then the next one, little lengthy, looks a little bit complex, but it's not, because again, what we are checking every time we check a condition, and the condition we check is, okay, branch not equal to. So again, assignment is done with add I. This is a revision, so I'm not going to explain that example in detail. But what you see is we assign a value, we check the condition, and the condition is met. We move to the next checking, or default, or we are outside. Okay, but if condition is met, then we execute this line. I think that's all that there is. And again, I went into loops. Loops, there are do while or typical while, and then for loop. But this is what I summarized. I think what I just explained a few seconds ago is that even in these ones, we check first conditions. So how many conditional branch instructions we have? That was in week 2, 6. Okay, so using one of those, we check the condition. We use variable initialization or assignment using this instruction. Then we have to increment or decrement, and we use this instruction. And then we use labels if you have to jump to a particular location. So using a combination of those, we can implement different loops. And we had implemented if-else case statements. Right? Then I give an example of a while loop. The book that I use is the Computer Architecture RISC-v edition from Sarah and David. This was while loop. And always, if it's not checking not equal to, we check for equal to. All right. Same thing in do while. The different thing in do while is first you execute these lines and then you check condition. This is for loop, so of course you start with this initialized value. And also, whenever we check against a number, and a number is, where is that number? Number needs to be in a register. So first you need to put that number in a register. Other things are pretty identical. Initialization, checking against that value in the register, then we increase it, right? And every time, first we check, right? We check the condition. If this condition is met, we exit the loop, go to the done, else we execute this. And we need to increment I, and we need to have this jump so that we can do that. Nothing is going to happen it's on its own. We have to put a jump here so that it can start executing next loop. Well, yeah, we look into arrays as well. So arrays, in summary, the data that is we want to put together because it's a similar data. We want to instead of pulling from different places, it's with a sequence. Okay, so sequence of data that we have put initially assume that okay, it's put entire word, and entire word is 32-bit, and every new 32-bit location is addressed with increment of 4 on the address size. So this was kind of a revision of what we look at on the memory architecture and how you can address this and the contents of the memory. So first example was, okay, we have an array. We go until a certain point, and then I mentioned, okay, how you can access this, how we can go up in the memory. We look into ASCII characters, how we can store those, how many of those. And we mentioned that since these are bytes, so now we need to be able to load a byte, to store a byte. Within loading a byte, we can load, because we are loading into a 32-bit register. So when we're loading only 8 bits, it's not like registers are not byte addressable. Okay, so one register is entire 32 bits. If you writing only to 8 bits, you need to worry about what you're going to put there. So if it's a signed number, you need to replicate the signed bit. If it's unsigned, then zeros. Using some examples, we try to learn this more. Okay, we also learned that, okay, just like byte, there is a 2-byte or half word. So 16-bit type of instruction as well, which we can use. We didn't look into the examples, but examples are pretty identical to these. Okay, what did we? Yeah, I gave homework to people. I did that homework myself. I didn't see anybody putting the homework or saying, if you did this homework during the week, please say yes, so that I know that some people are moving along with me. But the benefit of this training is whenever you get time, you can do it. But I told people that, okay, you just need to give me maybe 30 minutes every day. 15 minutes to watch my video, 15 minutes to revise something or do some of these examples or homework. That's it. So every day, 30 minutes, give me. And in few months, you'll become expert of RISC-v, this base core. And then gradually, little bit, within a year, you will learn the whole chip design with me. Okay. All right, we started looking into functions. We studied two cases. The first case was a very simple function, no arguments, no return, no point of function, but we just look into it, understanding the process, okay, understand the assembly. And that's where we started looking into register RA, what it does. And we also look into JAL, JR, these two sections that were in the beginning of the week. We said we're going to look into it, and here those came. When you make a function call, what do you need to do? What are the two key things that you need to do? We look into that. In the case 2, we started making into some proper function that does something. So it takes some arguments, it does some execution, and then it returns an integer. And we look into how arguments are passed, and those are passed through those registers A0, A1, 2, 3 up to A7. Okay, and then we use internal registers, and we said, okay, if it wants to return a value, it needs to store that into A0. And there's a handshake between the top level main function and the function. If it puts into A0, the main would know that that's where return value is. And we execute JR. RA is the register where you put return value. After it executes this, where the next instruction is located. So that's how much we look into in week 5. We're going to start looking into, okay, upgrading this function example more. And the first video will be on stack and how to use stack, how to save some of these internal registers on the stack. So the next week will be stack heavy, and we'll look into some other some other topics during the week 5. All right, slowly, gradually, and steadily, we are making progress, and I hope you guys join me in this training, and see you in the next video. Thank you. Bye.